Now the entire system has got improved 1,000 times. Now the terms is coined as IoT. IoT means the connecting anything and everything that is present in this world through the internet. Connecting anything and everything means connecting your shoes, connecting your pen, connecting your laptop, connecting your watch, connecting your mouse, anything that you want to connect. Now, why? First of all, how to connect it, and the most important thing is that why to connect it. Now, how to connect it? Suppose if I want to create this chair as an IoT enabled chair, that case what I have to do, that I have to give one unique address to this chair so that this chair can be identifiable in the internet. Now, what is that address will be called? That address is the IP address through which I can tag that computer, tag that chair. Now, I have tagged that chair, and also I have put one sensor, that is a pressure sensor, I'll be able to know that who is going to sit, if anybody is going to sit in my chair. If anybody is going to sit in my chair, immediately a pressure will be generated, and that information will go through some processor or microcontroller to the internet. Now the processor or microcontroller may be Raspberry Pi, that processor or microcontroller may be Node MCU, that may be Arduino, that may be Intel Galileo, anything it can be. Okay. Now, first thing is that, okay, obviously computer should not be, because if you connect to make chair IoT enabled, for that if you connect a computer itself, then the cost will be manifold. It is not possible. Instead of this, we can use the credit card size computer like Raspberry Pi, which cost only 3,000 rupees. Not only that, within the Raspberry Pi, you can see that there are 20 pairs pins are there, 40 pins are available. Those pins are called general input output pin. Now, out of these 40 pins, you can utilize 2 pins to connect the sensor that you have installed within your chair. Now, rest of the 38 pins will remain open. Now, you can utilize that rest of the 38 pins with some other sensors. Means, cutting long story short, that you can connect 20 sensor devices with a single Raspberry Pi, and you can make all those 20 devices as an IoT enabled device. Now there will be one problem. Problem is that each of the devices I have to tag it with an IP address. Now if I go for the IP version 4, you know that the IP version 4, the address length is only 32 GB. Now, sorry, 32 bit, I'm sorry. So IP version 4 length is 32 bit. Now with that 32 bit, you can give maximum 2 to the power 32 bit to the power 32 machines with a unique IP address. Now, if I want to connect anything and everything within this world with the IP address, will this IP version 4, this number of addresses are sufficient to connect all your devices, IoT devices? Obviously not. So for that, we have to connect IoT devices only through IP version 6, which have 128-bit length, and we can give 2 to the power 128 numbers of machines or IoT devices with the unique IP addresses. So first thing, to make your system IoT enabled, you must have to have your systems with the 128-bit IP version 6 enabled. Okay. Now, so my chair is connected, everything is going fine. Now, what are the IoT components? IoT components means, sorry, I could not create the figure yesterday, so I had to draw it actually. IoT component is basically resembled, you can resemble it with your TCP/IP protocol stack. You know that how many layers are there in your TCP/IP protocol stack? Can anyone tell me? Or in ISO OSI reference model, how many layers are there? How many levels are there?
7.
Hello? Yes? Yes, Josh, you can tell me.
7.
7, very good. Now, similarly, Yeah, for TCP/IP it should be 5. Very good. Okay. Now, yeah, in case of IoT, we have 5 layers. The lower layer is called the device layer, where your all things, all devices will be there. On top of it, your local network will be there, and on top of it, your internet. It should be internet. So your internet layer is there. Now, what is the difference between this local network and internet layer? Local network means wherever you will create the network, that network may be two types. One is infrastructure less network, another may be infrastructure based network. Now, if you create the network of the IoT sensors in a jungle or in a forest or in a war front, so that time you cannot expect, or in an agriculture field, you cannot expect an infrastructure-based network will be present over there. So that time what you have to do, you have to create a local network by yourself using either Bluetooth or using a 6LoWPAN. There is another network protocol is there, through which you will create your own local network, and through that one local network, one of the node will act as a cluster head, and that node will collect the data from the other node, and then it will try to send the data either through 3G or 3G or 2G network, or through your Wi-Fi network, through your backbone network. Okay. Now, if your IoT devices are there to connect in a smart home applications or smart home automation application, or your smart city projects or a healthcare application, there obviously those devices will be within the infrastructure based network. Okay. So that is why this internet layer and local area and local network is divided segregated separately for the IoT components. Next layer that will provide you the backend services, means that what I will do with those IoT data. Suppose I am collecting the temperature data. What to do with the temperature data? I need to come to a conclusion with those temperature data, means that I have to analyze those data. Before analysis, I have to check that whether all those data are filtered data or not, whether there is a spurious data or not. What do you mean by spurious data? Suppose you are collecting the temperature data and every time it is giving 22 degree, 23 degree, 22 degree, 23 degree. Suddenly you got a spike of 45 degree or 50 degree. Now, will this 45 degree or 50 degree, what is coming to you, is this the real data? Obviously not. Your temperature cannot be changed so much drastically. So those data will be called as spurious data, and I have to filter out those data. Or suppose a surveillance applications you have created, means that it is collecting the remote monitoring surveillance. Okay. Now, during the remote monitoring surveillance 24/7, all the data, all the media streaming data are not required. Video surveillance are not required for you. You will require only those data when you will find out one object is moving in front of your camera. So what should I do? I have to remove all those spurious data and I have to collect only the data that is required for my applications only. And on top of it, I have the different applications that I can see from my mobile or from my laptop for remote monitoring, etc. So these 5 components are there. These 5 components are also described over here also. If you have any question, you can ask me by this time. And I appreciate that you are asking me question, and this weekend after lunch, so it's a lazy time. So still you are there attending the classes. I am very grateful. One students have written one question, that is there any provisions for dedicated video memory, like there are some design software which require. Obviously you can find out that I have not chosen the GPU. You can choose the GPU. And do you know what is the maximum size of the GPU in the cloud? 64 GB. Is there any other question? Okay, so up to this much is clear, students. Shall I move? Students, shall I move? Okay, fine.
Yes, sir, you can continue.
Okay.
Chat box.
Okay. Okay, so this is the IoT network framework. You can see that the lower layer is your device layer. On top of it, you have the network layer, where For the infrastructure-less network, you have the wireless sensor network is there, and for the infrastructure-based, you have the 3G set-top box. Set-top box. Why the set-top box is mentioned over here? Because set-top box is utilizing the satellite communication only, and then Wi-Fi. And on top of it, you have the internet, and on top of it, you have the application layer. So this is also the same thing. That is a sensing layer from the device, and then you have the network layer and then service layer, and these are the different services. Okay. Now another thing is that what are the protocols are basically is being used, and I am again apologizing because I don't get the time to draw the figure, so I have to draw it handwritten drawing itself. So the component wise, what are the protocols are we are using, and what is the comparison between the IoT stack and the web stack? In the web stack, in the physical layer, we are using Ethernet, DSL, ISDN, or wireless LAN. Whereas in the IoT stack, we are using IEEE 802.15.4. That is being utilizing in the layer 1, that is physical layer, as well as in the MAC layer also. So it is a low data consumption protocol, which is used basically by Zigbee or by wireless HART, and its maximum data transfer limit is 250 kbps. And on top of it, the analogous with the network layer, you have the IPv6. Already I told that IPv4 is not being used over here. And 6LoWPAN. 6LoWPAN is the low personal area network. So which is also work in the low bandwidth, because for IoT, one thing is very much needed. One feature that is very much needed is that we need a network system which consumes a low amount of bandwidth, as well as it should consume low amount of energy also. Otherwise, your IoT devices or the sensor devices power will get drained down drastically. Okay, and in the transport layer, what is there in the web stack? We have in the IoT stack we'll use UDP and DTLS. DTLS is also another protocol stack which is being used for eavesdropping. That means to stop the overhearing procedure, as well as to stop the message forging. Okay, and on top of that, instead in the session layer, we have the MQTT, that is very much main features of your IoT stack. MQTT is basically message queue telemetry protocol, and another application is there that is called constant application COAP, and XMPP, that is the XML protocol. That means to send you the XML data. Now, those who are actually most of the terms maybe you are not familiar with, but I am telling you, you just remember this IPv6 only. Those who are already have gone through the networking, you know the IPv6, then MQTT, JSON, and XML. Now, what is JSON and XML? JSON and XML is a file format, universal file format to send your data. Now, in the web stack, to send my data and to get my data means that whenever we are writing www.gmail.com or google.com, we are writing it through HTML format. Now, the question is, you are writing it to HTML format doesn't mean that everybody will understand your HTML format, because the data, that means the web data, can go in different format, and different applications in the end user side may be different. Means that some of the end users have created their web application in PHP. Some of the end user may created their web application in ASP.NET or JavaScript or JSS or CSS. So there are several format of web applications. Now, if your web application is not robust, that case, one data that you have sent it in HTML and the end user is using PHP will not be recognized, and it will be immediately rejected. Means, in simple word, if you want to access some heterogeneous web application, you may not be able to access it. So to get out of this problem, what we are doing right now, that we have created two universal formats, which will be understandable, which will be recognizable by everybody, any application. and that format is XML and JSON, and they are very lightweight also. That is why the most of the time you can face this one, like whenever you try to purchase something through Amazon.com or Flipkart.com through payment gateway. That time you can see that your entire data is going through three different types of application. First, we have entered into Amazon.com. In Amazon.com, it may be created in PHP. And when you are going to pay your money through payment gateway like a Paytm or like Google Pay, the Google Pay or Paytm may be created in ASP.NET. Now, there is a dissimilarity in the data format. Now, for that, what they do that whenever from Amazon.com you want to go to click at Paytm, immediately your data will be converted to the universal format, that is JSON or XML. Yes, JSON or XML. So that your payment gateway side can understand the data packet format. Now from payment gateway, it will go to the bank side. Now bank side may be written in some other languages like ASP.NET. Again, if it is the data is sent in XML or JSON format, then they will understand it. There will be no issue. The same thing also happen in case of IoT stack also, because the one side I have the IoT devices, another side I have the different applications. Now they might be using the different types of web applications. Now until and unless I don't use any common format, universal format like JSON or XML, the data will not be recognizable. So JSON will be used for all kinds of IoT applications. Now the question you may ask that why we are not using XML, because XML is also one universal format. Yes or no? Because both are universal format. So here I am using only JSON, but what to do? What XML has done? Because we can send the data through XML also. The answer is XML requires much more higher bandwidth than JSON. JSON requires very less bandwidth, and already I told that we should use the applications where we require only less amount of bandwidth. Okay. So, is there any question in this part? Because this part is very crucial. Any type of question, students, because I know that you are from chemical engineering, electrical engineering, specifically non-computer background. That is why I want to know the question side from question pattern from your side. You can ask me any type of question. I'll be more than happy. I'll try to answer. But I expect that you should make the things crisp and clear. Okay, so as there is a question, so let us now go to the MQTT protocol. That is the most important protocol that is required for IoT services, and even for cloud IoT integration basically. Okay, so MQTT is basically a publish subscriber model, lightweight messaging protocol. So in conjunction with TCP/IP protocol. Right now we are sending our data. That means whatever I am saying, you can hear this one or you can view my screen. Everything is being done through TCP/IP protocol. Now, in case of TCP/IP protocol, what happens that it's a request response type protocol. Means that if you request it, that case from my side, the response will be given. But in case of MQTT, what happens that there will be two entity. One is publisher, another is a subscriber. Subscriber means those who request the data, and publisher those who will send me the data, publish the data. Now, when the publisher will send the data, they will send the data in different topics. Like suppose here IoT devices or the sensor nodes will be the publisher. Now the publisher can send the data. Suppose the currently his temperature data they can send, or the battery level data they can send, or they can send the data of the how many nodes are connected right now within this IoT connection in the remote location. That data that we can send. So for different kinds of data, the publisher or the IoT sensor device will create different types of topics. Right. Now, subscriber have to apply for what topic data you require. Now, subscriber means I am the subscriber. My mobile, through my mobile, I access the data, or through my laptop, I want to access the data. That means all will be subscriber. So I have to subscribe. That means I need the temperature data. But my mobile subscribe for other topic that they need only the how much power has been consumed by each of the IoT devices. Now, whatever subscription they want to do, they have to do it through the broker, IoT broker. Now, IoT broker will act as a bridge between the publisher and the subscriber. Now, publisher will publish the data of various topics. The broker will collect it and it will check that who has subscribed for what topic of data. And the broker will send the data as per the requirement of the topic to the different subscriber. Okay, so this is the basic concept. Now I am showing, okay, now why MQTT is required instead of TCP/IP? First thing is that it will ask for the remote connection. Remote connection is very easy. Second most important thing is that it's required limited bandwidth. Sorry, there is a typo is coming. So it requires only limited bandwidth of even if you have 500 kbps of bandwidth, it will work. And it is lightweight. You can deploy the application immediately. Okay, so these are the functions of publisher. That the publishers are the lightweight sensors, subscriber are the which they require the sensor data, and the broker which will act as a bridge between the publisher and the subscriber. And also it will classify that what type of topic or data is required by what type of subscriber. Okay. Now they have 5 procedure. Means that if I want to connect through cloud for some data, IoT data, that case I have to go for connect. If and after connect, I will go for subscribe. And whenever I don't require the data, I will go for unsubscribe. So if my connect 1-3 is clear, then I will be whenever the data will be published, I will be able to view the data. Okay. And if you don't want to connect with them, then go for disconnect and go for unsubscribe. Now, what is the difference between disconnect and unsubscribe? Means that the IoT publisher has 5 topics. Now, out of these 2 topics, I have subscribed. Now, I want to unsubscribe that 2 topics. I want to subscribe the other 3 topics. But I will be connected. But my subscription has been changed. So it doesn't mean that I am unsubscribed means I am disconnected. Is this clear, student? One question has come. Does MQTT use for only IoT devices? No, it's a very good question. May I know your name? Your name is Aditya. Yeah, it's a very good question. Do you know that 1 year before, when the pandemic situation was not there, that time most of the people who wants to use Zoom, because Zoom में connection बहुत आसानी से हो जाता है. Everybody can get the connection, whether the low bandwidth or higher bandwidth, no issue. Have you noticed that Zoom became very popular? Do you know why? Why Zoom used to work in a very low bandwidth connectivity? Because Zoom first time started communicating the people through video streaming through MQTT protocol. वो लोग उस टाइम पे स्टार्ट किया था. Let us try with the MQTT whether it is working or not. And whenever they started with the MQTT, they find out that with the minimal data connectivity, with the minimal connection, I can get the connectivity. Even if you have the half Mbps of bandwidth, 500 kbps of bandwidth, immediately you will get connected. There is no issue. But one problem is that the security issue. Because the IoT devices, whenever they are sending the data, security was not that much of concern. The much concern is that the power consumption, another is the low bandwidth. But whenever India government has published one circular that Zoom should not be used due to the security reason, immediately they have changed the MQTT protocol. Now it's clear, Aditya? Aditya, am I able to answer your query? Okay, fine. Great. Okay, so you can see an example of this MQTT workflow that there are two clients, three clients, client A, client B, client C. Now, client A is the publisher who is publishing the message, that he is publishing the message of speed is 15 mile per hour, and broker is collecting this one. Now, broker is checking that who is interested for this topic, that is the speed. Now he finds out that client B and client C is interested for this topic. Immediately, he is publishing this message to client B and client C. The client B may be your laptop, client C may be your mobile. Now this protocol uses a publish subscribe architecture, unlike the HTTP, uses the request response architecture. So publish subscribe is an event driven architecture and enable messages to be pushed to clients. The central communication protocol is the MQTT broker because it is acting as the bridge which is in charge of dispatching messages between the sender and the rightful receiver. And each client wants to receive messages subscribe to a certain topic, and the broker deliver all messages with matching topic to the client. Those who will match with that particular topic, they will be sent only the messages. Therefore, the clients don't have to know each other. Even the subscriber and the publisher does not have to know each other. They don't know, because they only know the broker. They will communicate with the broker only. And the architecture enables high scalable solution without dependencies between the data producer and data consumer. Means that if I want to connect with thousands of IoT devices with the 1,000 clients, one side is 1,000 clients are there who want the messages from the 1,000 IoT devices, immediately it can be deployable. Because they are sending the data in a not in a broadcast manner, not in a unicast manner. They are sending the data in a multicasting manner. The IoT broker is collecting this. They are matching that who is matched with this particular topic. They are sending the data to that particular client only. Okay. Now, one important thing is that that is called basically that wildcard. Okay. Now, a topic is a simple string that can have more hierarchy levels. Means that suppose for my smart home application, in my smart home applications, my tube lights or the incandescent light in my living rooms are connected, kitchen light are connected, bathrooms lights are connected. Now, I want the message of my living room only, or living room lights, whether it is glowing or whether it is put on or put off. Okay, so that case, what I can do that my topic may be of like this: house slash living room slash temperature. So this is the topic that I send it to the IoT broker. Now IoT broker will check that okay, that particular person requires the temperature of his house living room, so he will give that information only. Now on one hand, suppose the client requires not only the living room, he requires the information of all rooms. Now, if he requires the information for only the living room temperature, that case they can use a single level wildcard. Now, if I need the temperature of all the rooms, that case what should I write? I should write that house slash plus slash temperature. Means plus means that it should include the living room, as well as it should include the kitchen, as well as it should include the bathroom also, or kitchen, bathroom, whatever it may be. Okay, so in this way, you can write the topic either in the single level wildcard or in a multi-level wildcard. And now, what do you mean by multi-level wildcard? In case of multi-level wildcard, what I will do that I will write, instead of plus, I will write a hash. Means house space hash. Means that I need the all rooms temperature, plus I need the, apart from temperature, if there is any other pressure or other sensor devices are connected, I need the all sensors data of all rooms. That is called multi-level wildcard or multi-level hierarchy data. Is this okay? Is this clear, students? Okay, if there is no question, let us proceed again. Now, already I told that the MQTT does not have the earlier the security concern was not there. Now, right now they have changed one extension, that is the SMQTT. That means the secure MQTT. It is quite like instead of MQTT, what we use in case of our web application, we use the HTTP protocol, right? Now, for the secure HTTP, what we use? We use HTTPS. Now here also, instead of MQTT, we use the secure MQTT. It's a four main stage, that is the setup, and then encryption, then publish, then decryption. That means your data will be encrypted, go in an encrypted way, and then it will get decrypted. Now the IoT cloud integration in the cloud environment. Now using AWS IoT. Now already I have shown to you that AWS IoT is basically working as a bridge between your IoT device in one hand, another side is the IoT AWS, different AWS services. Means that suppose for a security surveillance camera, I need to stream the data, only the specific data only. That means whenever some intruders are passing in front of the surveillance camera, that time only I will process it and that data I will send it. Even some of the right now the AWS IoT has created one kind of application is that whenever your security surveillance camera will remain active, suppose you have 100 numbers of security surveillance camera is installed in the army base. Now they will capture the data in a low resolution mode so that the data streaming and the bandwidth requirement should be low. Now whenever some intruder will come, immediately they will process it. When they find out that there is a changes in the frame, immediately the resolution will get higher. So they will hide the resolution whenever some intruder will come. So who is going to do that? So that can be done with the IoT applications like Amazon Kinesis is one application which can do all those kind of applications. Or if you want to, whatever IoT data you are getting and you want to process those data, you can go for AWS Lambda. Or if you want to store the data in a database, you can go for AWS DynamoDB. Or if you want to store the data in an IoT storage device like your Google Drive, then their IoT has one storage option that is called S3. So you can store your data in IoT S3. Okay, so different applications are there. So you can connect your IoT device with the different types of applications. Okay. So this is the basic architecture that already I told, that if your devices are connected, that the home automation and home appliances devices are connected in the IoT in the cloud, the benefit is that whatever data are coming, the cloud can process all those data, filter all those data, and the filtered data can be sent for AI or machine learning applications, or if there is any other applications are required, that can also be done. Or suppose if you want to actuate, if you want to work for actuation process, that can also be done using this cloud IoT integration architecture. Now, why cloud IoT integration is required? First thing is that you can get a robust range of applications which are in the same place. As already I told that the whatever IoT data is coming, you can go for more than 50 different types of application as per your requirement. Those otherwise those applications you have to install in your system. First thing. Second thing is that the storage, because if you go directly connect with your local system and connect all the data, IoT data, that case your system will get exhausted immediately. Instead of this, if you go for the cloud storage, there is no unlimited storage space there, so that you can go for the data analysis and raw data filtering system. And right now, though we are using SMQTT, still they are producing others multi-layer security ecosystem. So if I get the time, I will show you the demo. That time I will show you that how the different ecosystems are being embedded in IoT. And also it keeps remote monitoring of your sensor node status. Means that it will keep monitor your sensor node, that whether your sensor node is alive or your sensor node battery gets drained down. You don't have to monitor it 24/7 manually. If your battery IoT devices sensor data sensor node get drained, immediately you will get the signal. and overall it is scalable. Means right now if it is connected with 100 IoT devices, no issue. Next day if it is 1 lakh IoT devices, that can also be possible. Okay, now this is the step-by-step procedure. How to connect your AWS IoT. Okay. Now there are two parts. From the AWS part, either you can connect with this system to AWS Management Console or through Software Development Kit. Software Development Kit is basically your CLI to which you can connect. Okay, let us start with this step-by-step procedure and workflow. Your sensor node is there. Now you have to first create a policy. That policy is called IAM policy. IAM full form is Integrated Authentication and Management. Means first the user have to authenticate themselves that they are valid user within this cloud. That if you are can prove yourself that you are a valid user, that case immediately you will be given the access of your IoT AWS IoT platform. Because in industry it is not like that a single user will handle all the IoT devices. There may be multiple users who may be there. So all user will be given one IAM identity, so that based on that IAM identity they will be identified, authorized and authenticated, and they will be allowed to access the IoT, their respective IoT devices. Okay. Now, next thing is that after creating the IAM policy, I have to register my devices, because from my side I have created the IAM policy. Now I have to register those devices which are placed in the different field or agricultural field or wearable device or whatever it may be. Now, why I need to register those devices? Because during the registration, I will provide one resource address. That means where you should send all your IoT device data to the cloud location, which location you should send it. And as well as whenever I will come to subscribe for a particular message, you should also able to identify me. So that is why this registration process is required. Now, bypassing this registration process and IAM policy, you can send the status of your IoT sensor through device shadow. Device shadow is basically a replica of your sensor. It's a small replica of your sensor. Means that from the device shadow, at any instance of time, I may come to know what is the current status of my device, IoT device. Now, after getting the device shadow data, I can send it directly to the mobile app. You might have seen that Blink app is one app is there. I am writing it in the chat. Forgot to mention it in this slide. So the app name is Blink. You can check it. It's a Google app. So Blink app. So using that Blink app, you can connect the IoT devices directly, bypassing this cloud integration process. But that case, all the data will come to your mobile and your mobile will get overloaded. Okay. So this is the basic workflow for 2, 3 and directly to mobile app. Now, instead of this, I will suggest you to connect and get the device shadow data to AWS IoT. After going through IAM policy and device registry, all those processes cleared. Now, after creating this IAM policy and registry, I will show you step-by-step procedure, and I will send it to AWS rules and action. Means that what type of application you require, based on this, your rules will be set. And your rules will be written either in SQL or in JSON format. Now, after setting up your rule, your all applications will be sent to AWS Lambda for processing. Now, if you don't require the processing, means that whatever data is coming, I want the data directly to my mobile, and it will be given directly to your mobile. Means that current temperature is 20 degree, 20 degree, 20 degree. Or instead of this, if you want the data like this, if the temperature goes beyond 30 degree, that time give me the notification. That case, you have to send your data to AWS Lambda. AWS Lambda will analyze the data. When they will find out that the IoT device temperature is right now more than 30 degrees, then immediately it will send a push notification to your mobile. Now, at the time of getting the notification in the mobile also, you can choose different option. Means that whether you need the notification in the form of a SMS, whether you need the notification in the form of an email, or whether you need the notification as the simple notification that comes to your mobile. आप लोगों के पास आता है ना different news or the update information to your mobile, such and such kind of notification. Huh? So that kind of notification also you can get. Up to this much, is there any question? I want to take 2 minutes break. By this time, if you ask me question, I will be happy. Sachin sir, can I take another 15 minutes?
Yes, sir. 15 minutes would be good enough.
Okay, sir. Students, quickly, can you come up with some question? Actually, I missed a few minutes in the beginning due to the network connectivity issues. Okay, so one students have asked me one question that is MQTT use TCP/IP due to ordering requirement. But what is the ordering? Can you explain? I could not get your question, Aditya. Can you unmute yourself and ask me the question?
Yes, sir. So, am I audible, sir?
Yeah. You are audible.
Yes, sir. Somewhere I read that MQTT use TCP or UDP protocol. So, answer was that TCP because of ordering.
No. For TCP is basically connection-oriented protocol. Means whatever data you are sending, until and unless you don't get the acknowledgement, the next data will not be sent. But if you use this type of ordering, then your data cannot be sent in a near real-time manner. So that is why the whatever data is sent, either it will be I have shown you now two protocols are there. One is UDP, another is DTLS. So either it will be sent through UDP or it will be sent through DTLS only. But for the web application, we can use TCP or UDP. Okay. Okay. So for the components of cloud IoT integration, so these are the components that already I have discussed, that you need the AWS IoT service a device SDK, which will act as a bridge between your IoT sensors as well as with your cloud devices. And you have the device gateway, which will act as the gateway to secure your data. So it will put firewall as well as it will check your IAM authentication, authorization, and after that they will allow you to pass those data. And you need the message broker, which will act as a bridge between your publisher as well as your subscriber. And you require the authentication and authorization that will be done through your IAM policy. And another thing is that the registry, that means your device you have to register through this one. And next is your device shadow. Device shadow is already I told that at any point of time, if you want to know the status of your device, that can be done through your device shadow. And another thing is that rules engine. Rules engine is basically I got the data. Now what type of application I want to put my devices, what type of information I require. Based on this, I will put it in either in Amazon Kinesis services or Amazon AWS IoT or S3 bucket. So it depends upon me. So I am showing you because as the time is very less, I am showing you a brief that I have a few IoT devices are connected in the tea garden. We have one project that is on behalf of the Assam government. We got it during the rainy season because in Assam the rain condition is very rainfall is very high. That is why sometimes the tea gardens the problem happens that due to the uneven plateau or uneven terrain, the water gets submerged into the T in the T in the T tree. Okay. So if the water is there in the upper surface, there is no issue. We can dry down this one. But if the water goes in the subsurface level, we cannot identify that one. For that, we have put several soil moisture sensor as well as the pH level. Also, we have to calculate the pH level also. Now, we have to remotely monitor the soil moisture level as well as the pH level of the different tea tree in a near real-time manner. Okay. Now, if we find out that the soil moisture is very high, that case immediately we have to arrange for the dry down, the drying procedure. And if the pH level is also get disbalanced, that case also you have to take the action. So what we are doing that we have already placed right now 75 IoT sensors in different places in the nearby tea garden, and we are remotely monitoring it. Now I am showing you from the IoT core service, AWS core, IoT core. So how we can access this one. So for you people, if you want to access this, what you have to do that go to service and write IoT. So you'll find out there are several IoT services there. You just click on IoT core. Now if you click on IoT core, click on monitoring. Right now the connection is not there. That is why my data is not showing over here. Earlier the data, okay, the connection is lost. Oh, anyway, so I am showing you how to create your AWS IoT configuration so that you can see those data also. Okay, I could not show it because I am showing it from AWS Educate account. And sign out from here, status. And I am actually it has been created from AWS console account. Just a minute. And sign in on my console account. Here you can see that either you can connect using a root user or an IAM user. IAM, that already I told you that it is an integration authentication management protocol. So if multiple users are connected within the same account, that case you have to use the IAM user, otherwise you have to use root user. So as my students are also connected with this account, so I have to use the IAM account. Now, before going to AWS IoT, one thing that I wanted to show you, show Shochin sir. Shochin sir has asked me regarding the billing. So you can see, sir, the billing option. Yes, here you can see that right now I have been incurred this month 0 INR. Okay, now my projected monthly usage is quite like this because due to as my all the devices are connected, all the IoT devices are connected, and I am using AWS IoT also, and I have paid the upfront fee already $400 for my IoT applications. So whatever cost will incur, so it will be deducted from this $400 only. So from this account, I can see and I can use the different services whatever I need. Okay. Now I am going to IoT. IoT, then IoT core. And then monitor. Okay. Right now you can see that. Okay. So I have total 14 connections are right now successful. Already I told that 75 IoT devices are connected. Right now 14 devices are connected, and rest of the devices they have some problem that we need to identify, and we can find it out, figure it out from the CloudWatch. There is an application called CloudWatch. From that I can figure it out from the log data that why they are not active. Either it may happen that the gardeners, those who are the worker over there, they sometimes put off the connection of those IoT devices, कभी कभी बैटरी चोरी हो जाता है, and sometimes what happens that the battery gets drained down. So right now 14 connections are there, and the messages that I received till now is at 92% MQTT messages and 7.3% HTTP messages, and ping messages 69%, and subscribe messages are 20%, and outbound messages 45%. Outbound messages means from my server to IoT devices, 45% messages has gone, and 54% inbound messages, that means from the IoT devices to me, the 54% messages is come. And these are the messages that are published, and these are the shadow update. Means that shadow means what? Shadow means the current status of my IoT devices. So they are giving us the get information, means what are the, if I ask for the get information, means whatever data is available with the IoT with the multiple columns, all the data will be sent to me. Okay, update data will give me that whether it is a live or awake, whatever it may be. And delete means some of the data they serially delete from their systems, because the Raspberry we have connected Raspberry Pi in few cases, and few cases we have connected Node MCU. Now Node MCU does not have that much of storage capacity, but in the Raspberry Pi, whatever data are being stored, so that are being deleted in a periodic manner. So this is the cloud integration dashboard. Now there is a step-by-step procedure is also there, but as the time is very limited, it will